Oh, okay, sorry. I was muted on the stream. This should be fixed, but just went over what was on the agenda. Okay, so to start, Dencun, the Goerli Shadow Fork, Harry or Barnabas, do either of you want to give an update?
Yeah, I can go. So we had the Goerli Shadow Fork this week. The network's consisting roughly of 300 nodes, split across New York, Frankfurt, Bangalore, and Sydney. We're running 100 validators per node, and then we initially synced the Goerli network and then forked it into our own shadow fork. Started with Capella, and Dencun was at Epoch 220. We didn't notice any issues with the shadow fork itself. Almost all the clients joined the shadow fork. We weren't able to sync Aragon in time, unfortunately, but we're going to shift to a snapshot approach next time, so that doesn't happen. But all the other clients joined the shadow fork successfully, and they all forked into Dencun without any issue. We were observing roughly 99 to 100% performance at the station as well as block production. And then we started blob spamming. So there's a link to the more detailed analysis that I've put up today.
So there were 0 blob transactions before that point?
Exactly. So for roughly a period of 1 hour, it was just Cancun and nothing else. And then you can see the massive spike in the overall network use graph, and that's exactly when the blob spamming began. So you're seeing nodes use roughly 700 kbps, so that's bytes per second, in the Cancun/Capella paradigm. And once blob spamming starts properly, you're seeing it at roughly the 900 kbps paradigm. So we can assume that there's a roughly 200 kbps increase with healthy blob usage. One caveat I will note is that the network's extremely flat. There are 300 nodes, and most of them have between 70 and 100 peers, which means you're going to be paired with someone from almost every region. So it's as perfect networking as you can possibly imagine. There's no clustering or anything that's happening, but also not particularly sure how to simulate the clustering or what would be useful there. And then we went on to the blob analysis itself. So we have a few blob spamming tools that we use. So we have Marius's TX fuzz that submits blobs, and we have PK910's Gumi blob spammer. We were targeting at roughly the 4 blob range. And if you look at the distribution, I think we've successfully hit like 3, with 6 being the least and 0 being the least as well. So I'd assume this is pretty much a scenario we'd also see on mainnet, because the target is 3. So most of the time we would likely see 3 blobs per block. The next one is the average blob propagation time. Most of the time, across 95% of the nodes, so this includes the ones in Australia, they're receiving all the blobs in under 2 seconds. If we don't include the P95 value and just take the average, it's under 500 milliseconds. And we have a couple more graphs as to how the effect of more blobs, what effect that has on network latency with respect to blob propagation as well as block propagation. The caveat is that for block propagation, the way different CLs emit their events is varied. So some might emit the first time they see a block without verifying it. Others might emit it after they've verified all the blobs. So just keep that in mind when you're looking at that graph at least. Yeah, and in terms of block latency, we see an increase of roughly 300 milliseconds. So the presence of blobs increases the latency by about 300 milliseconds. Attestations don't seem to be affected. They still happen at roughly the 4-second mark. So we're able to achieve everything we need to by, every node is able to have all the data it needs by the 4-second mark. Within the last roughly 2 days, we haven't seen any reorgs on this network. But I did post an alternate message on Interop yesterday as to periodic spikes we see, and the periodic spikes seem to be correlating with epoch transitions. So I think it's a known fact that epoch transitions are heavier. So we do see that the block or the slot at the epoch transition would take longer to propagate as opposed to the rest.
On the overall bandwidth consumption increase that we're seeing, you said 700 to 900, if I remember correctly.
Yes.
Do you have any insight if that is from the consensus layer or the execution layer? Obviously, you know, we're propagating blobs on the gossip, but we're also sending on the consensus layer. We're also sending in the mempool. I presume you're not sending these just through like builder networks. These are hitting the public mempool.
Exactly, they're hitting the public mempool. So we're not able to get the metrics per CL and EL. So what we've done is instead target the public interface. So this is just each node has one EL and one CL, and this is all the traffic that has come out and gone in from that public interface. There are some client-specific metrics that we can track, but the issue is that they're not necessarily standardized. So you might mean different things based on which client you talk to.
One way to get transparency on the ratio there would be to spam blobs, but only through, assuming, you know, we had nearly 100% builder network or something, only send them to builders through this, and then you'd see only the increase from the consensus layer because you wouldn't have any blobs in the public mempool.
Yeah.
So
that's true.
That might be interesting. Obviously, that's work, but could be interesting.
Yeah, we can give that a shot. I'd propose we try that on DevNet 12 though, because the other point we wanted to make is that we'd like to turn off DevNet Goerli shadow fork today evening. So if there's some last minute test, we can do it, but that's about it. And I've added the blobber a couple of hours ago. So it adds some latency of 1.5 seconds to random blobs. And currently, I don't see any effect of that. So I guess the analogous Yeah, the analogy on mainnet is if you have a random dispersion of, I don't know, 10 nodes out of 300 that are really slow in propagating things, there's no network-wide perceived impact.
They're not the originators of the message, though.
In some cases, they are. In sometimes they are. We're round robining which node we submit the blobs to. Yeah, I think that's all we had from the Goerli shadow fork. There was one thing that the red team wanted to look into with rate limiting, because we noticed these massive spikes once in a while, but I think they already have a PR ready for it. So.
Yeah, thank you. This is really valuable analysis. Any other questions, comments?
One last point I wanted to make was we've listed a link to every graph that I've referenced. The analysis is based on all the clients together, but there's a filter on top. So you can filter just for your EL or CL that you care about and look at per client behaviors. I think there's just too many clients to do individual analysis, but it would be awesome if you guys can have a look. The metrics are persisted for the next couple of months, so there's no need to do it before the network is torn down. Just adjust your time frame accordingly.
This is awesome, guys. Thanks.
Any other questions, comments on this? Okay, if not, yeah, I guess the next thing I was hoping to discuss was what to do in terms of next steps. A couple people reached out. Oh, sorry. Okay, before we do that, anyone opposed to tearing down the Goerli shadow fork by the end of today? Please voice your objection now.
Yeah, we want to look into the epoch transition thing, and so basically we are debugging it, and we might need some time for that.
Okay, so at least Lodestar.
Would you not be able to do that on DevNet 12 though?
On what?
DevNet 12.
So you are seeing the same behavior on DevNet 12 as well?
I would be quite sure that it's available. It's present on DevNet as well.
Okay, we'll basically look over there as well and see if we find we can replicate it there. Then, yeah, we can get rid of the Goerli shadow fork.
Okay. Any other team who wants to look at something on the shadow fork? Okay, so let's coordinate offline, but at least check with Lodestar before we shut it down. Okay, so yeah, next up, basically discussing next steps from here. So I know in the couple calls ago, we talked about potentially forking Goerli, assuming the shadow fork went well and that client teams were ready to do that. I'm pretty sure we had Prism run through the shadow fork and live on DevNet 12 now. So I'm curious to hear from teams like, is anyone uncomfortable with moving to Goerli as a next step? And if no one's uncomfortable, when would people want to see that fork happen? So yeah, maybe first question, anyone not ready to move to Goerli sometime in January? Okay, promising. And so if we were to fork Goerli,
just do we have consensus layer teams represented? I'm on mobile, so I'm kind of scanning through right now.
Let me see. At the very least, is there someone from Prism here?
That's what I was worried about.
Oh,
I'm here.
oh,
Oh, cool.
okay. So James, just to make sure, like from the Prism side, does like January for Goerli feel reasonable?
Based on what our team talked about, I think so. There's a couple of issues that we're still trying to work out, but it looks promising.
Got it. Um, so yeah, so if we want to fork this in January, I think we probably want to have the client releases out something like 10 days before the fork actually happens. So based on that, with teams, basically with teams, if teams are ready to like put out a release as soon as they come back from the holidays, then we could target something like mid-January. And then if teams feel like they might need a couple weeks coming back from the holidays to like polish things up and put out a release for Goerli, then maybe it makes more sense to target end of January. And the question is, one, do people have a preference there? And then two, is it helpful to agree on like an epoch or at least a tentative epoch today so that when teams are starting to put out a release, they can use that number? I guess if there's no objections or pushback, I would personally go first. Oh, okay, there's January 8th release around Prism. I was gonna say I would personally go for either the 17th or the 25th, which are two dates where we get like a midweek accumulator boundary slot. Does anyone have a strong preference between the 17th and versus 25? Okay, lots of people like 11 and 17. Some people like 1725. So yeah, I think 17 is a decent compromise. So from the row I had in the table on the agenda, this would be the epoch number. So it would be epoch number 231680 on the network. Start slot is 7413760. Which happens at 6 a.m. UTC, 6:32 a.m. UTC on the 17th, and then there's other local time zones on that. But yeah, let's do that. Obviously, if we find a major issue or something crazy before then, we can always cancel. But this would mean that ideally we're putting out the blog post for the fork sometime during the week of the 7th, the week of the 8th. So that people have, at least a week to update. So if client teams can target to have a release, at the latest on the 8th or the 9th of January, then we'll put up the blog post with all of those. And yeah, that should give people time to update before the fork happens. Any comments, questions, thoughts?
What's the timestamp?
I don't know. I don't know if Adrian added it to his website. He does. Let me just check this real quick. Goerli, the slot. I'll post the timestamp. I'll verify it offline, but I think this is the timestamp, what I just posted in the chat. Yeah, there's a comment by Ansgar around, talking about a best case, timeline between different test nets. I think historically, 2 weeks is the closest we've done. Just it's like the pace at which client teams can put out a release and have the testnet fork. Depending on how confident we are, one thing we can also do is have a single client release for something like Sepolia and Hosky. If we assume that, if Goerli goes really well and we assume Hosky is going to be trivial to fork once Sepolia forks, we can just have a client release and a single announcement telling people to update their nodes once, and that might save us a week or something. Aside from that, assuming we actually have like a client release per testnet, it's hard to do less than 2 weeks per testnet. And then between the last testnet and mainnet, we might want a bit more time for people to upgrade their nodes. Yeah. Okay, so yeah, let's aim for releases around the 8th or 9th. We'll have the fork on the 17th, and then from there, we can also figure out next steps for the other testnets, and if we want to bundle those releases. Anything else on, I guess, Dencun as a whole before we move on to other things?
Shouldn't we try to tentatively assign like plus 2 weeks from Goerli to the next testnet? And then in case something goes wrong, then possibly modify it instead of just waiting for Goerli to happen and then discuss when we could fork the next one. Because then we're going to be losing another 2 weeks at least in just discussing potential future fork times.
I'm not against it. I don't know how client teams feel about that. I would want to look at the numbers, not on the fly right now on the call, but like if people want to agree to rough dates now, we can definitely propose tentative. Like slots, and then maybe what we could do as well, if what we can do is propose tentative slots that go in like a 2-week motion if people are okay with that, and then reconfirm them on like the call 2 weeks from now, so that like teams won't have their releases out yet, and then if they want to already include that in a release, it still gives them a couple days. But yeah, I guess would anyone be opposed?
Tentative 31st and then 14th, and continually reconfirm after each of those forks.
And I guess my question for between 31st and 14th is, assuming we do Sepolia first and Hosky, do we feel like we need 2 weeks between those two, given, if Goerli and Sepolia have gone well, Hosky should be trivial. So I could see the value of doing
31st and 7th.
Yeah, 31st and 7th. I definitely would not want to bake in a mainnet date yet. Like I'd want to sort of roll through that and at least get Goerli and Sepolia like smoothly upgraded. But yeah, does anyone think that like 31st and 7th is too aggressive, or we should do something different? Okay, let's do that then. So I'll look at some epochs and slot numbers right after this call, but let's do Goerli on the 17th of January. Client teams have a release on the 8th or 9th that we can announce. Then we'll do Sepolia around the 31st of January and Hosky around February 7th. Again, assuming nothing goes wrong. If at any point we see something, we can always change those dates. But yeah, teams can start planning around that. And the implication as well being that we'd only have a single client release for the Sepolia and Hosky forks. So we'd want both of those coded in the network. And yeah, Barnabas, you have the question of did we agree to do Sepolia before Holski? I guess Sepolia feels higher risk than Holski, so if we are combining the releases, it makes sense to do it before, but I don't know if anyone has a counter argument to that.
Right, define higher risk.
So there's just like stuff on it, right? There's like a bigger state, there's more people using it. Whereas Holski is basically completely new. Although Holski has like a larger validator set, I guess. So
it would be earlier to catch some network-related bugs on Holski than Sepolia. So that's why I would personally prefer to fork Holski before Sepolia.
I think higher risk is also more informative too, right? If there's more people using this Sepolia, we might want to consider learning from it earlier.
yeah. But yeah, I guess it is a good point. If there are more validators on Holski, and the main thing we're concerned around is like networking and blob propagation, I think it's fine to do Holski first if people want to de-risk that.
Yeah, I could make pretty compelling arguments either way. I don't have a strong preference.
I guess, does anyone, again, aside from Barnabas, have a strong preference on ordering? The argument for Sepolia first is just there's more usage, there's a bigger state, but there are less validator nodes. Yeah.
So usage is also important for actual users testing things.
Yeah.
So like if that gives L2s an extra week to test where they're actually currently testing their environments, then that's a good argument for me.
Yeah, I don't know if any L2 people are on the call. I don't think so, but oh, Carl, yeah.
Yeah, I think that would be helpful. Most of the testing's been done in private so far, and I think it will also just act as a signal that, hey, this is really happening in the short term and might help have more robust deployments ready sooner around mainnet launch, because I think that might not necessarily be the case for some of the L2s right now. So the sooner the better, in my opinion.
Okay, so I guess that would bias me towards Sepolia first. I don't know how much is on Sepolia already, but I've definitely heard L2s wanting to move stuff to Sepolia if they haven't already. So yeah, giving them an extra week to do that seems reasonable. Yeah, okay, so I think I'd push towards sticking with Sepolia first. Barnabas, are you okay with that?
Yeah, sure.
Okay, so we have the schedule then. Goerli,
So just to state it out loud, like we picked the oldest testnet because if it borks, who cares? We picked the second oldest testnet because that will help users more than the newest testnet in terms of timing, and then the newest testnet. I just
Correct.
stated out loud.
Yeah.
It doesn't have to be a general rule, but like that is
Yeah.
reasonable logic, and maybe we'll reuse it.
Yeah, and I guess the argument to have done Holski first is if we cared less about user behavior, like on-chain behavior, and wanted to optimize more for validator behavior because there's just more validators on Holski.
It's not just really about the validators, but it's the number of nodes on the network.
Right.
And the Polio only has like 100 nodes or something like that, and Polsky has a significantly more. So blob propagation would be.
Holski is kind of like in the order of magnitude of the shadow fork we just did. At least based on some crawling. It's like 500-600. So it's not that big.
And what do you think Sepolia is?
Couple hundred, like 200 at max.
We could beef it up if we felt like it right before. Obviously, that doesn't beef up the validator nodes, but you'd still get deeper like block propagation paths. I don't know. I probably wouldn't advocate for that, but it is a possibility.
And I mean, both of these are also like an order of magnitude under mainnet, right? So it's not
Yeah,
like
definitely.
it's
Like
not like
significantly lower.
Holski is like 75% of mainnet and Sepolia is like 10%. They're both yeah.
Yeah, I think the most we're going to learn is from Goerli because the validator set is small enough. There are a lot of esoteric setups and so on. Holski just has a very large validator set size, which means by default, most people are just running really beefy machines with a lot of validator keys on one host.
Got it. Okay, yeah, so I think let's stick with the Goerli, Sepolia, Holski ordering. If we see something going wrong on Goerli, we can always readjust that. And, if we think that the next test being on Holski is better, we can just swap them around. But for now, assuming things go well, let's just follow that order. I'll come up with some slot numbers. After the call. But yeah. And then, clients should have the first release for Goerli, and then the second release after Goerli for the two other test nets. That makes sense to everyone? Cool. Anything else on Dencun? Okay, if not, next up, Ansgar, you wanted to talk about precompile address ranges and how how L2 precompiles may affect this.
Yeah, I mean, Carl has his hand up, I'm not sure.
I think Carl's hand is just still up from the last comment.
Okay, sorry, never mind. Yeah, so basically, but funnily enough, that's also Carl and me. So just to recap, we have recently started this RIP process, rollup improvement proposal process to standardize EVM and EVM related changes across layer 2 chains. Of course, purely opt-in, so it's not a governance call or anything. It's really just a standardization forum. And now, as we're starting to get the first kind of proposals through this process, we're starting to just kind of run into several kind of questions, and one of those specifically referred to precompiles. So you might have already, I think we already discussed on Alcodus as well, the potential future R1 curve precompile, SEC-P256 R1. And that now has an RIP number and is scheduled to go live on several rollups basically as soon as possible. They're all just waiting for it to be finalized in this process. And so the last remaining question we have is now for a precompile like that starts out as initially a layer 2 targeting EVM change. Should that basically take the next sequential precompile number that we have open on mainnet, or should that go into a separate range? And so the one kind of nuance that makes this not a trivial question, because I think initially a lot of people had the intuition that kind of a separate range for layer 2s might be better. But the problem, of course, is that a lot of EVM changes that will start on layer 2s first will at some point later potentially come to mainnet, especially in the future. We would expect that most EIPs actually start on layer 2s because they just ship things faster and then later on potentially come down. And so of course, we wouldn't want to have them be on a separate address on mainnet from layer 2s. So then that would mean that if we give layer 2s their own precompile ranges, that would mean that now on layer 1, we would at some point also start shipping from that new range, which is a bit weird. So alternatively, of course, we could just keep one continuous range, and then that would mean that at some point in the future on mainnet, once we ship future precompiles, we might start to have gaps where there's just no precompiles for a few addresses because they are only on layer 2s, and then some that we shipped on layer 1. So that's kind of the trade-off here. And given that, again, like a few layer 2s really want to ship this R1 precompiled soon, basically the hope was that we could kind of just make at least like a decision, maybe one-off decision. Ideally, of course, a more systematic decision here, how we want to treat this. Yeah, and the one nuance maybe, because Holger also asked on the call scheduling GitHub issue, there will be some sort of registry as well, like a meta RIP with a list of all the precompiles and the different layer 2s that they are shipped to. And we haven't created that yet, but we are in the process of also setting that up. And then the question is, if we decide to have one continuous range on layer 1 and layer 2s, is that enough to basically just have this kind of list of precompiles in the RIPs repo, or would core devs then also prefer to have some sort of meta EIP in the EIPs repo as well that kind of clearly lists which precompile addresses are basically blocked? So yeah, those are basically two questions that I would have for people.
Thank you. Danny?
Given we don't know like how much, I'm pro adding a range for L2s. And if there is significant adoption of an EIP before L1 adopts it, to use disjoint sequencing and use what was selected from that range for L1, because it's very unclear at this point what's going to happen with RIPs in terms of like, is there going to be one EIP for the R1 curve? Yes, probably. But you could imagine maybe there's two, because there's splintering in terms of like what one L2 wants to do in relation to another L2. Then we also have to think of what is that EIP being adopted on L2s? What is an L2? What makes it in that range? There's all sorts of these like questions which could make that space quite utilized, could make that space quite fragmented. Obviously, I know that's the goal, is to avoid a lot of those things. But as we don't know how that's going to happen, I don't think it makes much sense to like give it the mainnet allocation range at this time, and to instead like pick from it if we want to use it. Obviously, like having disjoint ranges is also kind of annoying, so I understand the argument the other way, but I think this gives us just better optionality as we kind of watch the L2, the RIP process unfold.
I think we will be having disjoint ranges anyway, because like no matter how we do it, in the end there will be EIPs that are, or RIPs that are finalized that will not make it to mainnet, and so there will be unassigned precompile addresses. I would also prefer the RIP process to have their own disjointed range. Like, it doesn't really need to be disjointed, but we could say something like, okay, from like, I don't know, like address 256 upwards is the L2 range, and the address 0 or 1 upward is the until 256 is the normal range.
And Marius, if for example they selected one from the range on the above 256, and then say it was the R1 curve, and then L1 was going to ship that same exact functionality, would we then utilize their number? Is that what you're suggesting?
That's the other question. I'm not 100% sold on just using what they propose. I think there needs to be a debate about that, and it kind of feels like Ansgar is just like proposing this as it's a given that we adopt the same address, but I don't think so.
What's the rationale for not?
Fair.
What? Yeah.
Well, that's what I'm saying. Like, there's a debate to be had around this, and I of course like it would be preferable for users for smart contract devs to have the same address, but
it's really a matter of how this manifests in compilers and things most of the time, right?
Right. Yeah. And I guess my question is like, is there an advantage to having the same functionality at two different addresses? It feels like it might only just create additional risks or confusion. So I'm trying to understand what's the argument for having like the R1 curve at address A on an L2, but address B on an L1.
Encumbering L1 to L2. For example, if the R1, if all the L2s we're like, oh, actually, we're going to modify the deployed EIP and functionality,
Right.
like at that address. Then they might modify, extend, etc. And now L1 is using something different than L2's.
Okay,
These things can move independently.
Yeah.
So I would that's my main argument.
Okay.
So to be clear on that, an RIP process will enforce that if you do want to do that, once we agree that something is finalized, you need to deploy a new RIP, and you'll have to use a different address because that's horrendous UX on the L2 side as well.
That's I don't know. That's kind of debatable in my opinion as to when you're adding new functionality, whether if it's an extension of functionality or just a minor breaking change of functionality, then you do change things. Like self-destruct, we changed for good reason. And so things that are calling a previous place still get a different functionality. So like that's certainly a precedent for changing functionality at an address space.
I mean, I think if that's a concern, then we should deploy RIPs as EIPs to the same address as the RIP, and then like the mainnet thing just follows the whatever is said in the EIP. But I don't know. It just seems silly to like potentially lose out on all these synergies just because there's a potential for change in the future. I feel like we just default into a worst case scenario unnecessarily.
Yeah, I disagree just because the practicalities of how I've seen things upgrade in the past. But obviously, like it's optimal from a certain perspective not to change things once they've been deployed.
Ahmad? Yeah.
One concern about this is that if the addresses are not the same, then there will be like different versions of compilers, and like compiler developers will have to deal with like different versions of the compiler for each network.
But they would have to do that anyways because on L1, even with a separate address range, on L1 that address is nothing, and on L2 it might be a precompile, right? So they're going to need ideally two versions, but not n versions. So I don't think.
And there is certainly like network specific like metadata depending on compile target as well.
Yeah. Ansgar, I don't know if you raised your hand again.
Yeah. I just wanted to briefly say because I also didn't want to make it sound like, by the way, that I assumed that was a given. Of course, that was just kind of an opinion. I wasn't aware that there might be kind of opinions against ever kind of deploying L2 precompiles at the same address. I think it's fine. We can discuss this, and if this is something that basically we don't feel comfortable at least committing to yet, which it sounds like we are not, then I think that would mean that we also already have an answer for my other question around the precompile ranges, because then we should definitely not use the same range, right? Because if we, of course, use the same range, then we're kind of committed to shipping at the same address. So then I would say, kind of as a takeaway from today, we should just give L2 precompiles their own separate range. Maybe question, are people generally okay with 256? That seems like a very sane default. And basically 0x whatever 256 and upwards. I mean, of course, not 0x, whatever the hex that is. And then we can basically discuss this once we move closer to actually shipping one of those precompiles to layer 1, which I could imagine might be the R1 precompile relatively soon, but then we don't have to make that decision today.
Yeah, that seems reasonable, where we can always choose to take 0x256 if we want to go that route, or 0x10 if we prefer. Yeah, does anyone disagree with the 0x256 range? If not, yeah, and I guess we should probably put this in like some informational EIP or RIP, or at least somewhere other than the transcript of this call to the highlight that we reserve 0x. I guess we would reserve 256 onwards for L2s. Like maybe we want to bound that range, at least for now, to some, I don't know if it's like 100 or 1,000 precompiles.
We already have a bound, and that is 0, like basically we have 0 to 1024 is the bound of the precompiles.
Okay. Okay, so we're saying that then.
Should we just flip the upper bit and call it half the range rather than starting at 256?
I feel like we'll probably have more than a 1-to-1 ratio, though.
So you're proposing 512, right?
Yeah. It's essentially like the bit flip signals which one you're on. That feels natural to me if there's compelling arguments about like the ratio of the amount that we'll see.
Yeah, I feel like 3-to-1 feels more reasonable. Like if you look in the history of Ethereum, we've shipped 10 precompiles in like 7 years. Some of the EIPs, have a bunch of precompiles they want to add, but feels unlikely we hit 256. But I can see L2s.
Yeah. I mean, just
500.
because
yeah,
there's a lot more degrees of freedom on who's doing innovation and on what. So it's a compelling argument.
Could it be possible to have a range that's actually starting from 0xFFFFF, like all the way at the end of the space and having it decreasing so that you can extend it as much as you want? It will never clash.
Well, you cannot extend it as much as you want.
But you don't have to decide where they're going to meet.
Yes, you can. Yeah. You don't. Yeah, exactly. You don't have to worry where the range starts because you know where it starts. It starts at the not FFF all the way because it's been reserved for other chains, but FFFE, for example, and just have it decrease and decrease and decrease.
Are there some like weird gas costs arguments to that? I don't think so, but the fact that it's 0.
That definitely are.
Yeah. So I think
like
if you're loading. Sorry, go ahead.
Yeah, if you call into a precompile that is, or like if you're loading the address of a precompile, you can just add a push 2 instead of push 32.
So how about we do 512?
Push -1.
How about we do 512, and then if we ever exceed the 512 on the L2s, we can give the sort of second 256 range back to the L2s, which will be kind of ugly, but something we can deal with 5 years from now. Does anyone disagree with that?
I mean, we could also just add another 1024 on top of it if we ever needed to, and give that to L2s as well.
Right.
Which would give us that 3-to-1 ratio, whatever, it doesn't matter.
Yeah, but I think 512 probably gives us room for like several years, and we can revisit this, or other people can revisit this in 5-10 years and think we made a really bad decision.
Or we can revisit ourselves and think we made a bad decision.
Yeah. Okay, so let's do that, and then I think an informational EIP probably makes sense because we want L1 to be aware of this, and then we can have RIPs that like reference the range or something. I think if it's just an RIP, then someone just looking at like L1 stuff might not know that we have reserved this range. So I would add an EIP for this.
Okay. We can ask Kanaka to get that. Sorry, go ahead.
No, I just want to say, just to point it out though, because we have had the similar conversation in the past, that people are generally uncomfortable actually having layer 2 specific information in an EIP. So the EIP would literally just say that basically the upper half of that range is blocked for mainnet, and then to actually see which of these addresses correspond to which layer 2 precompiles, you'd have to go to the RIP repo.
Yeah.
Does that sound like a good
Yep.
system?
Yeah, exactly. But knowing that on L1 we should deploy anything in that range, I think is what we want in an EIP. Yeah. Sweet. Anything else on this? Okay. Okay, next up, real quick, we discussed this a bit last week on ACDC, but in the next couple of weeks, with regards to Awkward Devs, we said we're gonna skip a formal Awkward Devs next week, potentially have a testing call at 14 UTC on Thursday if people want to show up and organize something. The week after that, January 4th, given we're gonna want client releases shortly after, it feels like we should have an Awkward Devs call, but I just want to check, does anyone feel strongly that we should not? Okay, so we'll keep the call. I will be out, but Light Client will be running the call. So he'll see you all there in 2 weeks. And then last thing on the agenda, we have this thread for the Prague and Electra EIP proposals. I went over it a couple days ago to compile sort of everything that's been proposed so far. There's been 2 more proposals in the last day, so 7547 and 7212. But aside from that, we have a decent list already there. I was curious to hear if anyone has thoughts about the overall set of proposals, anything they'd want to bring up now to discuss or bring to people's attention. I think at the very least, people should be reviewing this over the next couple of weeks. And as we move towards the testnets for Dencun, we should start, triaging through all of this sort of individually. But yeah, any initial thoughts, comments, questions from any of the teams?
Yeah, just one question. Are we still targeting a very short fork, a very small fork for Prague?
I don't think we've agreed to anything yet. So, yeah. Ansgar?
Yeah, I basically had a comment on that. I just wanted to say, because we are also actively working on EIP, one or several EIPs regarding adjustments to the kind of staking reward mechanism. I think related to similar how in Dencun we ship basically the throttling of the queues, just to make sure that we kind of never go out of bounds in terms of how many validators we have on Ethereum. And so while those are not quite finalized yet, I think in general it would be nice from that point of view if we did have enough of a fine-grained forking schedule that we don't have to worst case wait for 9+ months on a change once that becomes urgent with potential kind of developments in the total amount of staked ETH and whatnot. So in principle, there would be a preference towards having more of like a small-ish fork that we can still ship by the end of next year, at least. Instead of one that like really bundles everything that might be delayed until, I don't know, mid 2025, and then we basically are not very reactive in case we need to make small adjustments.
One additional thing to note is a number of the consensus layer proposals are not and do not have to be cross-layer. So there is an ability to make an independent decision here on a lot of those EIPs if the execution layer is going to be digging deep into a big feature.
Right, and I think on the EL side, the big fork is basically, do we choose to do Vercold now and then prioritize it? And, we might include other EIPs alongside Vercold, but effectively, we'd only ship the fork when Verkle is ready, and just generally any large feature has taken us over a year to ship, whether it's the merge, obviously, whether it's 4.4 that we're working on now. So I think if we do go down the road of Verkle, at least on the EL side, we shouldn't assume it's going to go live in like less than a year, right? And I mean, we can hope and like work hard and whatnot for that, but like if there's something that actually urgently needs to go live before that, bundling with Verkle seems unlikely to have it go live in like less than a year.
And yeah, Andre, my read is there is demand to get some of these things out on a consensus layer in 2024. And so we can just keep that in mind as we're making the decision on that side.
Guillaume?
Yeah, just to be clear, nothing should go at the same time as Verkle. It's such a complex thing that there's too much risk. I mean, if it's activating, even if it's activating some precompiles, I would prefer seeing a like small-ish fork that takes 3 months to release. I know it's never been done, but if it's just for a precompile, it might be doable. I would rather have that than anything happening at the same time as Verkle, because once again, the complexity is bonkers.
I guess, on that.
You're really selling it.
Yeah. On that then, I think again, with like the 3-month thing, it's hard to like realistically commit to that. And I think the reason is there's never just one precompile we want to ship. Like if we want to have a fork, there's a bunch of stuff that's going to want to be included. And there's like high fixed cost to shipping a fork. So we should probably bundle a bunch of things together. By the time we're bundling, 3 to 5 EIPs, it's basically, more like a 6 to 9 month thing. So I think it's fine to do that, but we should not tell ourselves like, oh, we're going to like choose the things and like fork in April after we've chosen in January because it's only one thing. That said, I think what we did do this time around is we sort of pre-committed 4844 to the fork after while we were working on the withdrawals fork. So if we wanted to ship a bunch of smaller things on the EL side, whether coupled or not with the CL, and then slowly start working on Verkle in parallel and sort of pre-commit the next fork to that is something we can do as well. And this way we can get all the smaller things out earlier, but also sort of reserve the next fork for Verkle in advance and potentially have parts of the teams working on it in parallel. And I guess maybe like this is probably the main thing that would be good to like agree on in the first couple of weeks of next year, regardless of like what the small EIPs are. I think, on this thread, everybody can get a feel for like the type of stuff that's being proposed, but are all client teams, like do client teams want to do, at least on the EL side, something before Verkle or not? And then if we agree to that, early in January, we can then figure out, okay, what are the things we want to do before Verkle, and this will give us a good idea of like, how long this fork is going to take. And maybe on Verkle specifically, like Guillaume was just saying, it's a pretty huge change. I know there's been the Verkle implementers calls and there's the website now, and Josh has been doing the summaries on Twitter. But do people feel like it would be valuable to maybe dedicate part of like the ACDE call to go deep in Verkle and have people sort of understand exactly where things are at and potentially ask some questions? Would it be worth having a call like that like early next year so that we can zoom in to the details?
Good idea.
Okay, so Yeah, let's maybe do that. I don't want to like schedule an exact date. We can maybe play it a bit by ear, but I think if teams want to start looking at everything around Verkol, start looking at all the other smaller EIPs and get a feeling for, do we want to do those EIPs before Verkol? And if so, do we have preference on which ones? We can discuss that in January and then find a time, even if it's not like a full Alcor devs, maybe have like half of an Alcor devs focused on just going deep into Verkol so that we sort of know what we're getting into, or at least what the current state of things is. Any other questions, comments? Okay. Anything else anyone wanted to discuss before we wrap up? Okay, if not, we can leave it at that. Thanks, everyone. Yeah, let's get Goerli out for Dencun and hope everybody has happy holidays.
Hey.
Thank you.
Everyone.
Happy
See you next year, y'all.
Thanks, all.
Thank you.
Bye.
Bye.
Merry Christmas.
Bye.
Bye.
Happy holidays.